Hi, good afternoon. Myself Chaitanya Madhivati, working as assistant professor in Vasvi Engineering College from past 4 years. I have a total experience of 8 years. Today, my topic is rectilinear and curvilinear motion of a particle in mechanics for the mechanical engineering. The unit is Unit 4. It is nothing but the rectilinear and curvilinear motion of a particle. In this, the topics are D'Alembert's principle, work energy method, and application of a particle motion to the and impulse momentum. So, first I will start with the brief introduction of what is engineering mechanics. It is classified into two sub branches, which is the first one is statics, and the second part is dynamics. So, as you all of know that statics is nothing but the body is in rest position. The body is in rest position and analyzing the various forces on the body. So when coming to the dynamics, it is nothing but body in motion. So it is further classified into kinematics and kinetics. So kinematics, and it is further classified into, it is a sub branches like kinematics and kinetics. Kinematic means which deals with, it is a branch of dynamics which deals with the bodies under motion and neglecting the forces. Kinematics means nothing but kinematics. It is a branch of dynamics which deals with the bodies under motion and neglecting the forces which cause the motion. So kinematics is nothing but a branch of dynamics which deals with the bodies under motion. So here the motion is nothing but actually, if you consider one car or freely falling ball from the upward, and the car is traveling on a road. So here we consider only motion and we neglect the forces which cause the motion. So this is nothing but kinematics. So in this we discuss about particle and rigid bodies. So the particle is nothing but, in this kinematics we can classify it for particle and for in this we can classify as for particle and for rigid body. So particle is nothing but, you can say that the particle means only considering the mass and neglecting the volume. So that is nothing but a particle. Particle means only we consider the mass of that body and neglecting the volume. If you consider one car which is towing up the hill, in this we will not consider about the size and shape of the vehicle. So we only consider about only mass of the body. So that is nothing but particle. And in rigid body is nothing but it does not deform under any load. Rigid body is defined as rigid body is defined as it rigid body is defined as doesn't deform under the it does not deform under the load or force. So that is a definition of rigid body. And another definition we can give it as, so the rigid body is defined as it does not deform under the load or force. So the another definition we can say it as the distance between the any 2 points doesn't change. So if I am considering some irregular shape of a body, so in that I am considering some point 1 and some point 2. In this I didn't apply any forces here. So after applying the several forces, so the distance between these positions should not change. So that is nothing but rigid body. So in this session we will dealt with the particle and rigid bodies. So particle is only considering the mass, and the rigid body is nothing but considering the whole element with the volume. So that is nothing but rigid body and particle. For this I am applying for the kinetics and kinematics. And next, kinematics means, so after that, so kinetics, it is also it is branch of dynamics. It is a branch of dynamics which deals with the body under motion, and also considering the it is a branch of dynamics which deals with the body under the motion, and also considering the forces which cause the motion. In this we can consider, in this kinetics we can consider for the both, we will consider both we have to consider both motion and forces, whereas in the kinematics we will only consider about the only motion and neglect the forces. In this kinetics we consider the both motion and the forces, and this is also applicable for the both particle and rigid body. This is also considered for the both particle and the rigid body. So this is a brief introduction about the kinetics and the kinematics. So this is all about engineering mechanics. In that, my topic in this unit is nothing but dynamics, that is kinetics and kinematics. Kinematics is nothing but which is a branch of dynamics which deals with the bodies under motion and neglecting the forces which cause the motion. For example, is that a car traveling on a, and in this we only consider only motion, size and shape we doesn't consider for the particle. For the rigid body means we consider whole the body. So in the next topic we will consider about the, so after coming to the kinetics, it is a branch of dynamics which deals with the body under motion and also considering the forces which cause the motion. So in this we will consider both the motion and the forces. So in this also we will discuss about the particle and the rigid body. So going to the kinematics, so I would like to say few, going to the kinematics, I would like to say a few concepts about the basic concepts. Those are, so these are very important, that is what is meant by motion. So first definition you have to learn that what do you mean by motion. Motion is nothing but it is defined as, so it is defined as a path covered by a body or object. We can call it as a body or object. It is defined as a path covered by a body or object it is defined as a path covered by a body or object with respect to the surroundings within a so this is nothing but motion. It is defined as a path covered by a body or object with respect to the surroundings within a reference time. So for this example, I am considering one car. So it is traveling with some velocity, some acceleration. So in this, it is at the point A, and from it moved to point B. So that is nothing but from point A to point B it has moved. So that is, we can say it as it is a defined as a path covered by a body. From A to B it is covered by a path. So from A to B the path is covered. So that is nothing but motion. So from one reference plane, so from one reference point to the second reference point it has moved. So we can conclude that is also a motion. So that's why I can say that it is defined as a path covered by a body. So from A to B, it is nothing but path with respect to the surroundings in a stipulated time or with reference to the time. If the body is covered from point A to point B within a stipulated time, that is some 10 seconds or some 1 minute or some 1 hour. So within a stipulated time, the motion you have to consider from A to B. So this is motion. So in this there are different type of motions are there. So motion can be broadly classified as in this kinematics. So first one is rectilinear motion. So, and second one is curvilinear motion, and the third one is projectile. So projectile motion. So these are the different type of motions which is dealt in the kinematics. So nothing but rectilinear motion. Second one is curvilinear motion, and third one is projectile motion. So rectilinear motion is nothing but the body so rectilinear means the body travels in a straight line path. So that is nothing but a rectilinear motion. So when coming to the curvilinear motion, so for the examples of the rectilinear motion is nothing but a car is traveling from A to point B. So point A to point B in a straight line. So that is nothing but rectilinear motion. So rectilinear means in the other name we can call it as a linear motion also. So or a ball falling from the down from the building. It is also a nothing but a linear motion. So linear motion, or the other name for the linear motion is nothing but rectilinear motion. So second one is curvilinear motion. So curvilinear motion is nothing but it is also a motion in which the object is traveled in a curved path. So that is nothing but curvilinear motion. So in this we will having tangential and normal uh, velocities. So we will discuss about in the velocities. So projectile means the object is traveling with some inclination. So in this curvilinear, the car is turning. So in this, I have a turn like this. So in this, from point A to, so from point B, so the car have to turn. So at the turning, it is nothing but curvilinear motion. That is the motion which is in the circular. So that come under curvilinear motion. And the projectile, if an object is thrown vertically upward with an inclination, that is nothing but projectile. So in this later on session, we will discuss about all the three. So rectilinear, curvilinear, and projectile motions. So first of all, when coming to the rectilinear motion, so rectilinear motion. So first part is rectilinear motion. When going to the topic rectilinear motion, I have to say few basic definitions like what is path, first one, and second one is distance, and the third one is displacement, and the fourth one is velocity, and fifth one is acceleration. So these are the different basic definitions which you have to know when going to the rectilinear motion. So first how to know the path. Path is nothing but it can be defined as it can be defined as so it can be defined as so path it can be defined as nothing but traveling of one position to the other position is nothing but we can describe it as a path. So when coming to the distance, it is the So distance, you can say that it is the total length covered by a body during the motion. So I will take the examples later by explaining the displacement also. So third one is displacement. So displacement is nothing but the shortest distance between the 2 points. So the shortest distance between the points is nothing but displacement. Indirectly we can say that is so I will take about the first I will take the example. One object is traveling from O to A. So one object is traveling from either the object is maybe it is a car or nothing but ball, anything we can consider. So I'm considering about one from point O to point A. So point O to point A. So in between I have placed point B. So here the distance is nothing but distance covered by a body is nothing but O to B plus B to A plus A to B. So this is the total distance covered by a object or a body. So when coming to the displacement, displacement is nothing but the shortest distance between the body, the shortest distance between the 2 points. So here I am taking as the shortest distance is nothing but OB. So the body is traveled from O to first O to B, B to A, then again A to B. It is the final distance covered, but our displacement is nothing but O to B. So the distance, it is a scalar quantity. And when coming to the displacement, it is vector quantity. So nothing but scalar quantity which is only having magnitude, the direction is not there. But for the vector quantity, it is having both magnitude and direction. So the distance is scalar quantity and the displacement is vector quantity. And when coming to the velocity, so velocity is nothing but the rate of change of displacement with respect to time. The rate of change of displacement with respect to respect to time is nothing but velocity. So it is also a vector quantity. Which is having both magnitude and direction. So here the rate of change of displacement means it is denoted by V, which is nothing but final displacement minus initial displacement by time, nothing but. So it is velocity, the rate of change of displacement with respect to time, it is velocity. The units are, so it can be written as xf minus xi by t. So indirectly delta S by T. So the units is meter per second, because for the distance it is meter and for the time it is second. So we can represent it as a meter per second. So that is about velocity. And when coming to the velocity, acceleration, so when coming to the acceleration, it can be defined as the rate of change of velocity with respect to time. So that is nothing but acceleration. So it is defined as rate of change of velocity with respect to time. It is denoted by small a, which is nothing but final velocity minus, so rate of change means nothing but it is a differentiate, so it is nothing but subtraction. So final velocity minus initial velocity by time. So it is also a vector quantity. So for the acceleration, units are meter per second square. So it is acceleration is dv by dt, which you can I can be represented as dv by dt. So that is final velocity minus initial velocity. So with respect to time, so it is all about distance, displacement, velocity, and acceleration. So further going to the first slide. So here the rectilinear motion. So the rectilinear motion is further classified into three categories. That is nothing but, so the rectilinear is further classified into rectilinear motion is further classified into, so first one it is constant velocity. So second one it is constant acceleration, and third one it is variable acceleration. So in constant acceleration, that is acceleration is 0. So for constant velocity, because velocity is nothing but, so here at constant velocity, so acceleration is 0 because acceleration is nothing but final velocity minus initial velocity by time. So if I am considering some path like this, so O, B, C, and some A I am considering. So from O to A, the distance travel is 4 meters, and B to C it is 3 meters, and C to A it is 3 meters. So if I am considering with a constant velocity, that is here it is 4 meter per second, and here it is 4 meter per second, and here also it is 4 meter per second. So if I consider it is constant velocity, that is final velocity. If you consider from point C to A, I am considering from C to A, the initial velocity is 4 meter per second, and final velocity is also 4 meter per second. So when you substitute in the acceleration, means it is nothing but acceleration is 0. So when coming to the constant acceleration, the acceleration is here constant. For that, we have to derive the equations. We are having 4 different equations. So in the further classes, we will derive that. And in the third one, it is variable acceleration. In this variable acceleration also, we will discuss about 2 categories. That is, first one is integration method, and second one is differentiation method. So in the further classes, we will discuss about rectilinear motion, about constant velocity, constant acceleration, and variable acceleration. And after that, we will move to the kinematics. That is nothing but, it's not kinematic, it's curvilinear. And after that, we will move to the kinetics. So in that kinetics, we will discuss about the D'Alembert principle and all of this. First, you have to learn the basic concepts like what is constant velocity, constant acceleration, and variable acceleration. So with this session, I am ending this about the class. So thank you.